times two square root.
Perfect. So what you're trying, basically, if the question says simplify, what you're trying to do is in such a question, you're applying the distributive law. What does the distributive law states? You're supposed to distribute this number to this number and this number in the other bracket. And then you're supposed to distribute this number to this number and this term in the other bracket. So
Yeah.
if we start doing that, that's 5 multiplied by 5. This has a plus sign and this has a plus sign as well, remember? Whenever whenever two addition signs they interact, the sign stays positive. So 5 times 2 is going to be 10 square root of 2. In fact, instead of just multiplying it first, I'll just write the original numbers here. So that's 5 times 2 square root of 2. Now let's start with the arrows which are in pink. I'll make them again. Here we go. Let's multiply this first and then this first. So negative 2 square root of 2 multiplied with 5, what would it give you?
Would be minus 10 square root 2.
Perfect. So instead of writing the answer first, what I'll do is write the brackets. And now let's move on to the last part. If I multiply this with this, what will we write? Instead of giving me the answer, why don't you just tell me what I'm supposed to be writing in the form of brackets?
Minus 2 square root 2 and next to 2 square root 2 again.
Perfect. Now if I multiply this, what do I end up with?
Minus 4 square root 2.
No, I'm talking about
all of it.
these two numbers.
25.
25. And if I multiply these two?
10 square root 2.
Plus 10 square root of 2. And then these two?
Minus 10 square root of 2.
Perfect. And lastly, these two?
Minus 4 square root 2.
Minus 4. Whenever square root of 2 and square root of 2 get multiplied, for instance, square root of 2 times square root of 2, is that equals to saying, take a good look over here. We're going to use one of those rules to help us come up with the answer. Is that equals to saying 2 raised to the power 1 by 2 multiplied by 2 raised to the power 1 by 2? Whenever we have the same basis, what do we do with the exponent?
We times them together.
We add them together. The 2 1 by 2 plus 1 by 2. What's a half plus another half?
Just 1.
1. 2 raised to the power 1. So basically, essentially, when we multiply these two terms together, we get 4. And when we multiply square root of 2 with square root of 2, what do we get?
1, 2. Yeah, 2.
2 raised to the power 1.
Yeah.
Is that making sense so far?
Yeah.
Now, what are we supposed to do? We've got some addition and subtraction signs. We're taking away something, we're adding something. What should the final answer be? What do you think? If we do not plug this into the calculator, just by looking at it, which terms are similar? Which can we group together?
10 square root of 2 and then again 10 square root of 2.
So if you have 10 square root of 2, take away 10 square root of 2, this basically essentially ends up being a 0.
Just 0. Yeah.
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 If we add a 25 to it, and what is 4 times 2?
Just 8.
Since there was a negative sign, remember, do not forget that. Add 25 to 0 and then take away 8. What are you left with?
Add 25 to 0 and just take away 8. Oh, 17. Is that what you mean?
17. Right? Does that make sense?
Yeah.
All right.
Yeah.
Here we go. Since you asked for the chapter for surge, the concept of surge asks us to rationalize the denominator.
Yeah.
And to rationalize the denominator, these are the two rules that you should know.
Yeah.
Take a look over here. Can you read this?
To rationalize the denominator of a surd, if denominator has a single term, multiply numerator and denominator by that term.
All right. So, for instance, the question looks like this, and you're supposed to get rid of the square root sign in the denominator. What you're going to do is multiply with the square root sign, same number in the square root sign in the denominator and in the numerator as well.
Yeah.
So, essentially, if you remember, we just did an example. Let's do it again. If we multiply, can we write square root of 5 like this?
Yeah.
All right. And if I multiply that with another square root of 5, what do we end up with?
Just 5 to
Just
the power
5.
1.
5 to the power 1.
Oh.
Remember? So that's how we remove the square root sign in the denominator. Although it comes in the numerator as well, but that doesn't really matter. It should not be in the denominator. Now, if you take a look over here, what's the second sort of example?
One, the
Double dashes basically mean I'm writing the same thing again. Instead of writing it, I'm just trying to save time sometimes. If denominator,
if denominator has two terms, multiply numerator and denominator with an expression with the opposite sign.
With the opposite sign. Now that might seem like a lot of technical lingo, but essentially what they're saying is this is what the question looks like. Multiply this denominator with this thing with the same expression again, and instead of a negative sign, plug in a positive sign. If it already has a positive sign, plug it with a negative sign, and vice versa.
Yeah.
Does that make sense?
Yeah.
All right. So do you have both of these rules down?
Yeah.
Okay then. Here we go. Let's put them to the test. Would you be able to solve this?
Yeah. Would it just be 5 square root over 5?
What I'm guessing you must have done is multiply square root of 5 in the numerator and denominator.
Yeah.
Did you end up with the same answer?
Yeah.
All right. Yes, perfect. Can you give me the answer for part 2?
Yeah. Just 3 square root 3 over 3.
Come again?
3 square root 3 over 3.
3 square root 3 over 3. Let's see.
Yeah.
If I were to multiply this with square root of 3 and this with square root of 3, I will end up with 3 square root of 3 over 3. Well done. Well done. Give this a try. Part 3.
Yep. How would you multiply them together?
Do you remember the rule where we multiplied two brackets together?
Oh, yeah.
So I think what you gave me was the term that you told me was something foil, if I'm not wrong.
Yeah.
If that works for you, try it with foil, or if my method is easier, try that. essentially you're supposed to multiply the first term with both terms of the second bracket, and then the second term with both terms of the second bracket.
Yep.
So let me do one question with you. Take a look over here. What's the rule? What am I supposed to multiply this with now?
6 square root plus 2.
All right. So let me write that down. 6 square root plus 2 and 6 square root plus 2.
Yeah.
If I multiply these two together, I end up with square root of 6 plus 2. And what happens in the denominator? This is where the calculation gets a little tricky. Take a look over here. 6 square root minus 2. And I'll write it again. 6 square root of plus 2. If I multiply this with this, I end up with just 6. If I multiply this with this, I end up with 2 square root of 6, right? Now I'm going to apply the same rule with the second term. Minus 2 square root of 6. And if I multiply these two, minus 4. Take a good look over here. The first two, the second and the third term, they cancel out. We just left with 6 minus 4, and that comes out to be 2.
Okay.
So would you be able to apply the same concept on the last sample question that we have?
So would you do it for both ends then?
Come again?
Would you do it for both the numerator and denominator?
Not quite. Rationalizing simply means you're supposed to remove this sign from the denominator only. So you just need to worry about the denominator.
Okay.
But yes, you're supposed to multiply whatever you're coming up with in both the numerator and denominator. But in case you're left with a radical sign in the numerator, do not worry about it. Let's just solve it together. Why don't you keep on telling me the steps and I'll write them down. So what should my next step be?
You should do times it by 3 plus square root 2.
And same thing in the denominator?
Yeah.
Okay, what do I end up with?
Do you need to find out wait.
Can I write them together like this? Take a look.
Yeah.
Now, once I've written them together like this, what can I do in the next step? Now, this seems familiar, right?
Yeah.
Okay, so
you'll do yeah. You 5 times 3, which is and then you'll do 5 times square root of 2. That's nice.
Next.
And then you do square root of 2 times 3.
Mm-hmm.
And then square root of 2 times square root of 2.
Excellent. And what happens in the denominator?
In the denominator, you in the denominator you do 3 3 times square root of 2.
When we start off with 3 times 2, sorry, 3 times 3.
Oh yeah, 3 times 3.
Then?
And then 3 3 times square root of 2.
Mm-hmm.
And then minus square root of 2 times 3.
Minus square root of 2 times 3.
And then minus square root of 2 times square root of 2.
Excellent. I'm going to rearrange the terms a little bit. Take a look if they still make sense. If I multiply these two, I'll just write that 15. 5 square root of 2 is perfectly fine, but I'll move this number over here and write it as 3 square root of 2.
Yeah.
Right? And if I multiply these two together, what do I end up with?
Just 2.
Just 2. Perfect.
Yeah.
Now let's go in the denominator. And what I'm going to do, once again, rearrange the terms a little bit.
Mm-hmm.
3 times 3 will give us 9. I'll write this again as it is, and I will write this number over here. All right, but in the next step. So I'll write it over here. Take a look. Minus 3 square root of 2.
Yeah.
And if I multiply these two together, what do I end up with?
Just 2 minus 2.
Minus 2. Let's solve this now. Can we cancel out these two numbers, these two terms?
Yeah.
Essentially because they have the same value, but with opposite signs, so we can simply cut them out.
Yeah.
So we're left.
Can we cancel out?
Come again?
I thought we could cancel out 2 as well. But
We can solve 9 and 2. They won't exactly cancel out, but we can solve them. So if we take away 2 from 9, what are we left with?
7.
7 in the denominator. Now what happens in the numerator? If we add 15 and 2, what do we get?
17.
17. And if we add 5 and 3, what do we get?
8. Yeah.
8 square root of 2.
Okay.
Is that making sense?
Yeah.
So you've essentially removed the square root sign or the radical sign from the denominator, and that's called rationalizing the denominator. That marks the end of the chapter. I have a few more questions over here. I'll just quickly walk through them real quick with you. Read this again.
We rationalize the denominator of a fraction when it is a surd. Rationalize means to turn an irrational denominator into a rational number.
Perfect. So once again, these are some examples of surds. We need to remove the square root sign from the denominator. What am I going to do? I'll multiply the denominator with square root of 6 and the numerator as well. So if you notice, I end up with a number which does not have a square root sign. Or if it does not have a square root sign, half of the job is done. Now I'll try to see if I can simplify these two numbers, 2 and 6 together. How many 2's fit into 2? 1. And how many 2's fit into 3? Sorry, 6, 3. I can then further simplify it and write it like this. And that is exactly what I've done. Is that making sense?
Yeah.
Let's do another example. The question will just look like this. 4 plus 3 square root of 5. What I chose to do was I chose to multiply both the numerator with the same expression, but in terms, this time around, I changed the addition sign to a subtraction sign. If I do that and apply the same distributive property that we've done a couple of times now, you will see that suddenly the denominator does not have a square root sign anymore. It vanishes. What I can do then is I see that there's a 4 in the denominator and a 4 in the numerator. I can cut them out and I'm simply left with 3 minus square root of 5. 3 take away square root of 5. Does that make sense?
Yeah.
Okay. Let me confirm that.
Thank you.
So if we were to multiply this, square root of 7 with the square root of 7 would give us just 7. Square root of 7 with square root of 2 would give us just 14,
Oh, okay, yeah.
right? I'll explain it as well. If I were to multiply 3 square root of 2 with square root of 7, that will give us 3 into 14. And if I were to multiply 3 square root of 2 with square root of 2, this will give us 3 into 2. Let me explain this concept. Let me explain how it works. What's troubling you is when you multiply the square root sign with another square root sign, you're ending up with this number, which is incorrect. Let me show you. If I were to rearrange square root of 7, I can write it like 7 raised to the power 1 over 2. And this can also be rearranged to be written as 7 raised to the power 1 over 2. The bases are the same. So we just simply add the powers. And that becomes 7 raised to the power 1, which is essentially 7. Let me apply that same rule to this number and tell you how this works. I accidentally erased the part which I wasn't supposed to erase. Now, if I were to multiply this number with this number, I can write 7 raised to the power 1 by 2. And I can write 2 square root of 2 as 2 raised to the power 1 by 2. Take a look over here. The bases are different, but the exponents or powers are the same. What do? We combine the bases and we just write the power together at once. So that's 14 raised to the power 1 by 2. Sorry, apologies. I made a mistake over here as well. This is square root of 14. Okay.
Okay.
And if we apply that same process over here, now we're going to multiply these two together. So what I'll do is I'll write them in the form of indices so that we do not make any mistake. 3 multiplied by 2 raised to the power 1 by 2 multiplied by 7 raised to the power 1 by 2. So let the 3 be as it is. We're going to write that once again similarly. Multiplied by, we can combine the 2 and 7 and then raise them to the power 1 by 2. I'll show you what I mean when I do that. I'll show you the rule that I'm working with. The rule I'm applying over here is this one. When you have different bases but the same power, you can combine the bases like this and write the power once.
Yeah.
Okay. Imagine if I give you an example, 2 raised to the power 3 multiplied by 5 raised to the power 3. Since the bases are different, I can write them down together and then write the power at once. That's going to be 10 raised to the power 3. I'm applying the same rule over here. It had the same powers, I wrote them once, and it had different bases, so I combined them over here.
Yeah.
So we're just left with, so I've essentially done this wrong as well. See, that's what happens when you try to skip the rules and just try to do it all mentally. Here we go. Square root of 7 plus square root of 2. Now, if I were to ask you to do it again, but only this part, how will you do this?
Would you just times square root of 2 with, would it be 3 square root of 4?
Almost there. So let's rearrange it and write it in the form of an index. 3 into 2.
Oh, yeah.
Right? Is that making sense now?
Yeah. Sorry.
If I were to rearrange it, I can write it like this. And if I were to rearrange this, I can write it like 2 raised to the power 1 by 2 if I were to write it in the form of an index.
Yeah.
When the bases are same, what do? We add the powers. So 3 comes down as it is.
Yeah.
2 raised to the power of 1. That gives us 3 into 2. And that is exactly what I've written over there. Now that we know our numerator is correct, if you were to apply the same thing on the denominator, can you help me solve that? Square root of 7 plus square root of 2. I'll highlight the values, and what if you give me the answers? You're multiplying this with this. What do we get?
Just 7.
Just 7. Excellent. And if I multiply this with this now, what do we get?
Would you do square root of 14? What is 14?
Square root of
Yeah.
14. Now let's see if what you've said is correct. 7 raised to the power 1 by 2 multiplied by 2 raised to the power 1 by 2. The bases are different, but the powers are same. What do? It's rule
Times
number.
base and add the power.
We times the base and we just simply write the power once. We combine it. That's square root of 14. Excellent. Now, if we were to multiply this with this, the orange part, what is the answer going to be?
Would it just be minus square root of 14?
Minus
Same.
square root of 14. But why?
Because it's the same process, just minus.
Same process with the negative sign. Makes sense.
Yeah.
And if I were to multiply this with this, what do I end up with?
Minus 2.
Minus 2. Now, if you quickly take a look, plus square root of 14 and minus square root of 14, they get cancel out. In the denominator, we're just left with the number 5. And what's the answer in the numerator?
Would it be? Would you have to do 7?
Come again?
Plus minus 2. Would you have to do for the numerator?
Yeah.
Would you do? Wait. Wait.
We're supposed to combine like terms, right?
Yeah.
So, which is the term similar to this term?
3 square root of 14.
3 square root of 14. If I add 1 square root of 14 to 3 square roots of 14, how many square roots of 14 do we have now? Same example that I gave you yesterday. 1 apple added to 3 apples. You're just supposed to consider square root of 14 as an article or as an item. So 1 square root of 14 plus 3 square roots of 14. So we have 4 square roots of 14. Does that make sense?
Yeah.
Now 7 and 3 into 2 combined would be, what you'll do is apply the rule BODMAS first and multiply 3 and 2. You'll end up with 6. Add 7 and 6 together. What do we get?
7 and
6.
yeah. That's I thought you said 7.
This is the answer that we ended up with. Let's see if this matches the answer that is down here. It does.